Hey guys, I wanted to go over the questions on this study guide with you, along with providing you an answer key so that you can have some verbal explanation as well. So, question number one says at 7 p.m. on January 31st, the temperature in Ellijay, Georgia was -3 degrees Celsius. By 10 p.m., the temperature had dropped by 10 degrees Celsius. Which of these gives the calculation needed to find the temperature at 10 p.m. along with the correct temperature at the time? So what we're looking to do right here is we're going to find out what essentially number sentence is going to give us the correct calculation for the temperature at 10. And then we also need to know what the temperature is. Well, looking back in our question at the information we have, we know that we were at -3 degrees Celsius to begin with. And then we dropped another 10 degrees. So when we say dropped 10 degrees, we're going in that negative direction. So this is really going to be a -10. So the questions that we have here say the calculation is -3 degrees Celsius plus -10 degrees Celsius, which gives a temperature of -13 degrees Celsius at 10 p.m. A is correct because we have -3 and then we're adding another -10. So -3 plus -10. And now when we want to add these together, we need to use our integer rules. Remember the song? Same signs add and keep, different signs subtract. Keep the sign of the higher number, then you'll be exact. So we have -3 plus -10. We have the same signs, so we're going to add them and keep them the same. So we get -13. So we do have here that A is correct. B is not correct because this would tell us that we increased 10 degrees, not that we dropped 10 degrees. C would not be correct because -3 plus -10 is -13, not -7. And then again, for D is incorrect because that 10 degrees Celsius is a negative, not a positive. So now let's look at number 2. What is the result of this subtraction? Well, the first thing we know that we have to remember, we have to follow the order of operations. And I'm just going to write them down here. Or please excuse my dear Aunt Sally. Do your parentheses, exponents, then multiplication or division, followed by addition or subtraction. So I see my parentheses here. So I'm going to start with everything that is inside. So I'm going to focus on my 1.8 minus 9.2. I'm also going to need to bring in my knowledge of rational numbers and my integers and positive and negative numbers. All right. 9.2 is bigger than 1.8. So we want to say, oh, whoa, wait, I can't do that. But yes, you can. Remember, we can change subtraction to show us addition so that we are now adding the opposite. Now I go back to those integer rules. We have different signs. So we will subtract and then we keep the sign of the larger number. So I'm just going to write over here off to the side 9.2 minus 1.8. I'm going to bring my decimal down so I don't forget about it. I can't take 8 away from 2, so I'm going to borrow from my 9. And 8 from 12 is 4. And 1 from 8 is 7. So we get 7.4. And now we have to look at which number is bigger so that we can find our sign. 9.2 is bigger and it's negative. So this is a negative 7.4. So now we have 5.2 minus negative 7.4. And again, now we're showing we are subtracting a negative. We're going to do the same thing we did here, and we're going to get rid of that subtraction. So now we're going to add the opposite. So now I'm adding a positive. So I'm going to go ahead and I'm just going to write this off to the side. 5.2 plus 7.4. I'll bring my decimal down so I don't forget about it. 4 plus 2 is 8, and 7 and 5 is 12. So we get 12.8. Nope, that should be 12.6. I'm sorry. 4 and 2 is 6, not 8. So 2 plus 4 is 6. 5 plus 7 is 12. These are both now positive, so we keep a positive 12.6. All right, let's look at number 3. Number 3 says, my daughter went to Anna Ruby Falls in Tennessee. It was an underground waterfall. The fall is 1,120 feet below ground level. As we were descending, we used an elevator that had 8 stops that were equally separated. How far below ground level were we after the first stop? So a couple of things that we need to know here is that the fall was 120 feet below ground level. So when I'm saying that this is below, this is telling us that we have negative 120 feet. So this is telling us this is a negative number. We know that the elevator had 8 stops. So basically what's happening, and I'll draw us a little picture, is we have our elevator going down. We have ground level at 0, and then the very bottom is at negative 1,120 feet. Now, the elevator stops 8 even times. So we'd have stop 1, stop 2, stop 3, stop 4, stop 5, stop 6. Whoops, I didn't give enough room. Stop 7, stop 8. So we have 8 stops in there. So that's what's happening, though. But ideally, between here and here is the same as between here and here. And here is the same as here and here. So all of these distances are theoretically the same. So I'm going to take my negative 1,120, and we're going to divide that by the 8 stops to find out how far we are after one stop. Okay, so after one stop, so I have a negative divided by a positive. Our rules here are different than they are for adding and subtracting. If you multiply or divide with the same sign, you have a positive answer. If you multiply or divide with different signs, you will have a negative answer. So I have a negative divided by a positive, so this is going to give me a negative answer. And then we just take our numbers and we divide as normal. Now, you could do this as long division, or you're welcome to use a calculator. And my calculator is huge in here. So if I use my calculator, I type in 1,120 divided by 8, and it's going to give me 140. And again, we're in feet. So each distance is 140 feet. So the question of how far below ground level are we after the first stop? This is going to be from here to here, which is simply just negative 140 feet. And it is important that you keep that negative, because if we said positive, that would be above ground level, not below. All right, let's look at number 4. Which expression is the simplified form of negative 15 plus 4h minus 2h minus 8h plus 21 plus 2h? So the big thing we need to look at here are our like terms. So I'm going to use a couple of different colors so that we can identify our terms. And I'm just going to circle them. So I have negative 15. So any term that is similar to my negative 15 does not have a variable. So I've got 4h. Well, that has a variable. 2h. That has a variable. 8h. That has a variable. 21 does not. And I'm going to include the operation sign in front of it because that actually does tell me if we have a positive or a negative number. And then lastly, we had another 2h. So now I can look at my h's. And all of my terms that have an h are like terms. And I'm going to continue to include that operation out in front so that I know if I have a positive or negative number. So now we're going to take our like terms and we're going to combine them. So I can start here. I have negative 15 and 21. So negative 15, whoops, negative 15 plus 21. Well, I have different signs. So the reality is I'm going to subtract and then keep the sign of the bigger number. So I'm going to rewrite this 21 minus 15. Can't take 5 from 1, so I'm going to borrow. 5 from 11 is 6. 21 is the bigger number, and it's positive. So I'm going to have a positive 6 in my answer. All right, so now we're going to take the blue. We're going to take our h's, and I'm just going to rewrite the h's all together. So I have 4h minus 2h minus 8h plus 2h. Now, sometimes the easiest thing to do here is just to go left to right. So positive 4h minus 2h. Just subtract the coefficients. We get 2, and we keep that coefficient. So I have 2h minus 8h plus 2h. So I'm going to look at my next pair, going left to right. 2h minus 8h. Subtract the coefficients. I have minus, so I have 2 minus 8. I really can't take 8 away from 2, but I could rewrite it as a plus negative. So we have different signs. We subtract, keep the sign of the larger number. So when I subtract, we have 6 left over. 8 is bigger, and it's negative. So I have negative 6h plus 2h. We're down to the last pair. So negative 6h plus 2h is, we have different signs. So we subtract, keep the sign of the bigger number. Okay, so 6 minus 2 is 4. 6 is the bigger number, so I'm going to keep that negative. And we don't want to forget the h. So now I'm going to take both of my terms, and I'm going to have them together in one sentence. So really what we have here is a negative 4h plus 6. This is our final answer. All right, number 5. In a science class, a student was measuring the temperature of a solution during an experiment. The solution started out at negative 1.3 degrees Celsius. After 3 minutes, the temperature had increased 22.5 degrees Celsius. After 3 more minutes, it had decreased by 26.2 degrees Celsius. After 3 more minutes, it had increased by 8.8 degrees Celsius. Which number represents the final temperature in the experiment? So what we need to do here is look at everything that is happening. So we start at negative 1.3. This is our starting point. I'm going to write that down here. 3 minutes later, we increased. Increased means we're going to add. So I'm going to come down here. I'm going to put an addition sign. And it increased by 22.5 degrees. So I'm just going to add 22.5. And then after another 3 minutes, it decreased. That means we're going to subtract. I'm going to put a subtraction here. And it decreased by 26.2. Then after 3 more minutes, it increased by 8.8. Again, increased. We're going to add 8.8. Now we're going to use all of our knowledge to add these numbers together. Well, add or subtract these numbers. So following our order of operations, all we have here is addition and subtraction. So we're just going to go left to right, depending on what comes first. So here I have negative 1.3 and 22.5. I have different signs. So really, I'm going to subtract and then keep the sign of the bigger number. Let me get us some more room here. So I'm going to write off over here to the side 22.5 and 1.3, and I'm going to subtract. So 3 from 5 is 2. Bring down my decimal. 1 from 2 is 1, and I can just bring down that other 2. So now I have 21.2, and 22 is bigger, so this is going to stay positive. Next, we have minus 26.2 plus 8.8. So looking at the next set, I have 21.2 minus 26.2. This is a subtracting, but this number's bigger. So really, I can't take 26 away from 21. So we change it to show that we're adding the opposite. And now I see I have a positive and a negative. So just like we did before, we're going to subtract, keep the sign of the larger number. So 21, no, we're going to do 26.2 minus 21.2. So 2 from 2 is 0. 1 from 6 is 5. So we're left with 5.0. 26 is the bigger number. So we're going to make it negative 5.0 plus 8.8. Again, we have different signs. So we're going to subtract and keep the sign of the larger number. So I'm going to write it down, 8.8 minus 5.0. Move this up some more so we can see it. 0 from 8 is 8. Bring down that decimal. 5 from 8 is 3. So we get 3.8. And then the question is it positive or negative? Well, 8.8 is bigger than 5. So the answer is positive 3.8 degrees Celsius. All right, number 6. Let's talk about Stella. Stella has X in her checking account. She goes to the dollar store and spends $23.75. Now she has $9.30 left in her bank account. How much did Stella have in her account before she went to the store? One way that we can do this one is looking at the information that we have. And let's write an equation. So we know that she starts with X dollars. We don't know how much it is. We're just going to represent that with the X. This is our unknown value. Well, then she goes to the dollar store and she spent $23.75. So she's spending money, so that money is coming out. So we're going to subtract 23.75. But when we do that, we know that she's left with $9.30. Now we have a one-step equation. So to solve a one-step equation, we look at what's happening to our variable. This is our variable X. We want to isolate it. We want it to be all by itself over here. But we're subtracting 23.75 from it. So we need to undo this. And the way we do that is by adding 23.75 to both sides. So we are left with x is equal to, when I add these together, 0 plus 5 is 5. 3 plus 7 is 10. We'll carry that 1, bring down my decimal. 9 and 3 is 12, plus 1 is 13. Carry my 1. 1 and 2 is 3. So she started out with $33.05. All right, number 7. An airplane is flying at 2,500 miles above sea level. The plane drops down 200 miles per minute. Where will the plane be flying after 3 minutes? So let's find out how far down the plane went after 1 minute. Okay? So if the plane is at 2,500 miles above, and then they went down 200 in 1 minute. They go down another 200 after minute 2, and another 200 after minute 3. So really, I'm just going to subtract 3 each, or I'm going to subtract 200 3 times. So if I have 2,500 or 2,500 minus 200, I get 2,300 minus a second 200. We're at 2,100 minus that third 200. We are now at 1,900 miles above sea level. All right, number 8. Get number 8 in here. So Mark has $100 in his savings account. He deposits $10, withdraws $53 to buy school supplies, and $16 to buy snacks. How much is in his account now? Again, he starts with 100. So 100 is my starting amount. He's going to deposit, so we're going to add in $10. We're going to add $10. So now he has $110. Then he withdraws 53. He's going to take that out. So that is a minus 53. So I can go ahead and subtract that out. I can't take 3 from 0, so I'm going to have to borrow. 3 from 10 is 7. 5 from 10 is 5. So now he's got $57. Then he buys $16 for snacks. That's another minus 16. So I'm going to take my 57 and I'm going to subtract 16. 6 from 7 is 1. 5 from 1 is 4. So he's got $41 left. All right, number 9. The temperature in a small town in Alaska was 5 degrees Fahrenheit. The temperature dropped 8 degrees and then dropped 4 more degrees 3 hours later. How much does the temperature have to increase to return to 0? So let's look at this. All right, so let's find out where it was. All right, we're at 5 degrees. So 5 degrees Fahrenheit. The temperature dropped 8 degrees. Dropped means we're going to subtract 8 degrees. So I'm going to subtract 8 degrees Fahrenheit. And if I go ahead and do that, I can't really take 8 from 5. So we're going to change that to show that we're adding the opposite. So now I'm adding a positive and a negative. I'm going to subtract, keep the sign of the higher number. So we have 3. 8 is bigger than 5, so we have -3 degrees Fahrenheit. But then it dropped 4 more degrees 3 hours later. So it dropped another 4. So again, I'm going to subtract 4 degrees Fahrenheit. I'm going to change my subtraction to show that I'm adding the opposite. So now I'm adding 2 negatives. When we add with the same signs, we add the numbers and we keep their sign. So I have -7 degrees Fahrenheit. So now we know what our temperature is now. But the question is, how much does the temperature have to increase to return to 0? So that's what I want to know. What does it take for me to get from -7 to 0? So if we're looking at this on the number line, if I am at -7, but I want to get to 0, how far do I have to go? So let's look. Okay, so let's count. It's going to be 1, 2, 3, 4, 5, 6, 7 to get back to 0. So this is 7 degrees to get back to 0. Remember, this is what's called a zero pair or additive inverse, where we take two numbers that are opposites, we add them together, and they get 0. Saying -7 plus 7 is equal to 0. Number 10. What is another way to write this expression? Well, anytime we have a minus, we always know that we can change that subtraction to adding the opposite. So if I do that, I have 67 plus -23. I can't change one without changing the other. So C is our answer here. Number 11. Suppose that A and B are rational numbers. Which expression is equivalent to A minus B? So this is very similar to that last question, except we don't have numbers, but that's okay. We can think of these just as variables. We have the variable A and the variable B. How else can I write this? Well, I have subtraction. I can change this to show that I am adding the opposite. So really we can say A plus -B, which here is A. All right, let's come over to number 12. We want to solve -13 plus -11. Keep using those integer rules. We have the same signs, so we add and we keep the sign. I could look at these answers and go, okay, I know that I have two negatives, so I'm going to have a negative answer. So I'm just going to go ahead and rule out B and rule out D because those are positive. So 13 and 11, if I add those together, 1 and 3 is 4, 1 and 1 is 2. Again, two negatives, we have a positive. This is a negative, two negatives, we have a negative. We get -24. Number 13, select all values equal to 4/5. This is where we have to remember what we know about negatives and how many negatives give us a positive answer. So I know that if I have an odd amount of negatives, the answer is negative. If I have an even amount, of negatives, the answer is positive. Oops. There we go. So really what I want to see as I look at some of these down here, I want a positive answer. So I need to have an even number of negatives. Well, for A, how many negatives do we have? 1, 2, 3. These are 3 negatives. So this is equal to just negative 4/5, which is not positive 4/5. B, 4 over negative 5. This is 1 negative. Again, this is still equal to negative 4/5. I have a negative and a negative. 2 negatives, not 3, just 2. So here we have 4/5. Now it's tempting to stop right there and say, oh, C is the correct answer. But notice it says select all values. So let's check the rest of them. So I have 2 negatives. So that's a positive 4/5. And E, just one of those is a negative. So this one is not. So here we have C and D. Number 14. Ashley uses 3/4 cup of milk when making pancakes for one person. How many cups of milk does she need to make pancakes for 6 people? Well, we know that there's 3/4 for 3/4 cup for one person. But we need this for 6 people. So there are 2 ways that we could do this. We could say 3/4 plus 3/4 plus 3/4 plus 3/4 plus 3/4 plus 3/4. We could do that 6 times. Or we can multiply and say 3/4 times 6, because we know that multiplication is repeated addition. So rather than adding 6 times, I'm just going to multiply once. So here I have a fraction and a whole number. I need to make this whole number a fraction. Anytime we do that, you just put it over 1. And multiplying, we multiply straight across. So I'm going to say 3 times 6 over 4 times 1. So 3 times 6 is 18, and 4 times 1 is 4. But we can't leave our answer like this. We must convert this back to a mixed number. And remember, the fraction bar represents division. So I can say 18 divided by 4. 4 goes into 18 4 times. So 4 times 4 is 16. When I subtract, I have 2 left over. So I know that I have 4 and 2/4. But now looking at this 2/4, I can simplify that down. So I have 4 and 1/2. You could simplify up here. You could see that, hey, 18 and 4, those are both even. 2 will be a factor of both. You could simplify here, and then you wouldn't need to do it down here. But if you didn't simplify here and you simplified down here, that's fine. So we know that she's going to need 4 and 1/4 cups for 6 people. Number 15. Find the product. So here we go. We have 7 times -3 times -2. Well, if you remember, we looked back when we were doing number 13. We could use the rule that if we have an odd number of negatives, we have a negative answer. But if we have even number of negatives, we have a positive answer. So I can go ahead and identify the sign and rule out a few of these. So I have 1, 2 negatives. I have 3 numbers, but only 2 of them are negative. So that means we're going to have a positive answer. So we can rule out 42 and or negative 42 and negative 294. And now we just take these three numbers and multiply like normal. So 7 times 3 is 21 times 2 is 42. And again, that is positive. If you wanted to, instead of doing it this way, you could look and say 7 times negative 3 times negative 2, and then just work each one. Well, 7 times 3 is 21. Positive times a negative is a negative. So negative 21 times negative 2. 21 times 2 is 42. A negative times a negative is a positive. We got the same answer. So you could have done this one either way. All right, let's look at number 16. How do you write the fraction 2/5 as a decimal? Remember that that fraction symbol represents division. So instead of saying 2/5, I'm going to say 2 divided by 5. Now, 5 does not go into 2. So we must add a decimal and bring it up so that we have it in our answer. And I'm going to go ahead and put a 0 out in front of it just to represent that. Now I'm going to add a 0 at the end, and we can continue to add zeros as much as we need to after the decimal. 5 goes into 20 4 times. 4 times 5 is 20. Subtract. We get 0. We don't need to add any more zeros. And we get 0.4. All right, number 17. Heidi's profit for selling her homemade cakes was $14 during the first month. Which expression represents Heidi's total profits if her profits continue at this rate for 8 months? So we know her profit, okay? Profit means we are in the positive. We are in the positive. That's 1 month though. So she makes $14 in 1 month. If she keeps going, how much will she get in 8 months? So we could add 14 8 times. Or we can simply say 14 times 8. These are both positives. So anywhere that I have a negative, I can rule that out. And we're left with 14 times 8. Number 18. Which expression is equivalent to the expression below? Remember, equivalent, we're looking for things that are the same. So what we want to do here is we want to see what simplifying we can do to this expression. Well, in my parentheses here, I have 3a plus 7. I can't really do anything in there, so I got to leave those. But looking over here, I've got plus 9 times the quantity of 5 minus a. We can use the distributive property here. So 9 times 5 and 9 times a. So what I have here, 9 times 5 is 45, and 9 times a is 9a, and we're subtracting, so I'm just going to bring that subtraction down. Now I've got these numbers here. I have 3a plus 7, and I'm going to bring down the other addition. Okay, I'm not going to carry down the grouping symbols because now I want to combine these together. So I'm going to find my like terms. And now that all I'm doing is adding or subtracting, we can do that. So I'm going to find my a's. So I have 3a and negative 9a. And then we have positive 7 and positive 45. So 3a minus 9a. Okay, we're subtracting, so we can change that. So we're adding the opposite. I have opposite signs, so we subtract. Keep the sign of the larger number, which gives me negative 6a. And now I have my 7 and 45. These are both positive. So 45 and 7. 5 plus 7 is 12. Carry the 1 is 52. So we have negative 6a plus 52, which here is C. Number 19. William has a stack of dimes and a stack of quarters. There are the same number of coins in each stack. The expression below shows the total value in cents for the two stacks of coins, where C is the number of coins in each stack. So which expression represents the same amount of money? So what we're looking at here, we have 25C and 10C. This is how many coins are in each stack. So we want to combine these to find out how many represent our stack. So just like before, all we're going to do is add the coefficients and keep the variable. 25 plus 10 is 35, and we keep the variable C. So all together, William has 35 coins. Number 20. Mrs. Hickman hired a company to mow and clean her lawn. They charged $25 initial fee and $20 for every hour of yard work. The final cost of the lawn care service was $105. Which expression models the situation and is solved correctly to determine the number of hours H the lawn company spent working in her yard? So we know that they're going to charge her $25 regardless. Regardless of how much time they spend, there is a $25 fee. Now, for every hour, we have $20. So we're going to add to that $20 for each hour. They haven't told us how many hours, but they did give us a final cost. The final cost was $105. So now what we want to see is which one of these is the correct expression with the correct answer. So let's see if maybe we could mark any of these out. We know we have 25 plus 20H. All right, well, 25 plus 20H is equal to 105. That is correct. 25H plus 20 is equal to 105. That actually is the same. We've just switched the numbers. Oh, wait, no, I'm sorry, that's not, because the 25H, H is with the 20 hours, or the $20. So here we go, 20 hours, 20H does not equal 105. Now we have 25 plus 20H is equal to 105. So these two number sentences are correct, but we need to find out which answer is correct. So now we need to come over here and solve this. So remember, we want to isolate the variable. So I need to undo what's happening. Start with addition or subtraction. We're going to get rid of this 25. It's a positive 25, so we're going to subtract 25 from both sides. So now I get 20H is equal to 5 from 5 is 0. 2 from 10 is 8. Now we have multiplication happening between 20 and H, so we're going to divide. We divide both sides by 20, so we get H is equal to 80 divided by 20. Well, I know that's going to simplify down to 8 halves. So 8 divided by 2 is 4. So it did take them 4 hours. All right, here's number 21. Which expression is equivalent to, which is equivalent to 4x minus 14 plus 2x equals 70. So let's see what simplifying we can do here and find out which one that matches with. So I've got some like terms. I've got 4x and I have 2x, a positive 2x. So if I put those together, I get 6x minus 14 is equal to 70. Well, I have a 6x, but I don't have 6x minus 14. So let's keep going. Let's isolate 6x. So instead of subtracting 14, we're going to add 14 to both sides. So now we have 6x is equal to 84. And here it is right here at A. We get 6x is equal to 84. These equations are still equivalent to each other. All right, number 22. Guys, we're almost there. Katie made 2 withdrawals of equal amounts from her checking account. The equation below can be used to determine X, the total amount in dollars of each withdrawal. What was the amount in dollars of each of Katie's withdrawals? So what we need to do is take this equation and solve it. So I'm going to rewrite it down here so that I can show all my work together. So we have 600 minus 2x is equal to 547.24. So I have my 600 here because here's my variable. So we want to keep this right here where it is. I have a positive 600, so I'm going to subtract 600 from both sides. So now I have negative 2x. We don't want to forget this subtraction sign. We need to keep it. All right, and now I'm going to subtract 600. Well, wait, 600 is bigger. So we know that really this is adding the opposite. So now I'm adding a positive and a negative. Different signs, subtract, and keep the sign of the bigger number. So I'm going to come over here and I'm just going to show 600.00 minus 547.24. So we'll have to do some borrowing. I can't take 4 from 0, and I can't really borrow from that 0. So I'm going to come all the way over here. It's 5, 10, 9, 9, 9, and 10. 4 from 10 is 6. 2 from 9 is 7. Don't want to forget my decimal. 7 from 9 is 2. 4 from 9 is 5. And 5 from 5 is 0. So here on the right side, I get 52.76. But it's negative because 600 is bigger. And 600 is negative. Now, we're going to continue to get this variable by itself. Negative 2 times x. So I'm going to divide both sides by negative 2. Don't want to forget that sign. So we get x is equal to negative 52.76 divided by negative 2. We know a negative divided by a negative is a positive. So my answer is going to be positive. And we can break out the handy dandy calculator for this one. And I can say 52.76 divided by 2 is equal to 26.38. And again, that's positive. So her withdrawals were each $26.38. Number 23. John has 18 pieces of candy. That is 2 more than twice the number of pieces of candy that his little brother has. Which expression can be used to find C, the number of pieces of candy? So we know that John has 18 pieces of candy. So he's got 18 pieces, but that's 2 more than. So that's 2 plus twice what his brother has. So we have 2 plus twice the amount of candy that his brother has to equal 18. So here this just shows it flip-flop. 18 is the same, is equal to 2.2 plus 2c. Showing it either way, these are equivalent. It's the same way to show it. Number 24. Judy has paid $204.60 for groceries. That made 132 cupcakes. How much did Judy pay for each cupcake? So here we have the cost for 132 cupcakes. We want to know the cost for one cupcake. So we're going to divide. So $204.60 divided by 132. Break out that handy dandy calculator. All right, and we've got 204.60 divided by 132. Man, Judy's making a lot of cupcakes. So we get $1.55. And you are welcome to use your calculator. Calculators will help improve your accuracy. All right, last question. Here we go. Miguel went to the store and bought 3 pounds of strawberries for $5.35. What was the cost per pound of strawberries? So we know that we're looking at the cost per pound. So I'm going to set up a ratio, my money and my pounds. So it was $5.35 for 3 pounds. So we're going to divide. And again, we can use our handy dandy calculator, that magical piece of plastic, and we can say 5.35 divided by 3. And money is always taken to the second decimal place. Money never goes past that. So we're going to round it off to $1.78. All right, guys, I hope that seeing these problems worked has helped you out as you prepare for your interim assessment. If you still have questions about any of these, please let me know.